subsurface drip irrigation, otherwise known as SDI. There are over 170,000 acres lurking beneath the soil in Texas, and that number continues to rise. As technology continues to evolve, more and more farmers are choosing to invest in SDI for their cotton crop. To help explain what a subsurface drip system is and why this method is has been increasing rapidly, let's take a look at what a drip system is and what its components are. I have received all of my information regarding the drip irrigation system from a local drip company, EcoDrip Irrigation, and its founder, Hubert Farrington. The first step in preparing to convert your farm into a drip irrigated farm is to shoot a map of the land using a global positioning system, otherwise known as GPS. This measures the elevations of the land within a 99% degree of accuracy. The yellow lines shown here are the GPS lines done by the map. From this, a drip system designer takes the GPS and makes the design of the field. They then make a list of all the materials that they need for the system. The layout begins with breaking down the field into different zones that are irrigated separately. We will now take a look at the individual components of the drip system and their importance to the overall working of the structure. The filter, shown here in blue, is extremely important because all particles have to be removed from the water before flowing through your system. There are many types of filters, such as sand media filter, in which the water passes through sand and then is filtered. This is important so that you catch all particles that you do not want flowing through your system. The next picture shown here is a chemical check valve. This is installed by the filter, and it is where all chemicals and fertilizers are injected into the water. It prevents any chemicals from moving backward into your water supply. The supply line, shown here, is made of large PVC pipes, usually 6 to 8 inches in diameter, and it carries the water to the head of the field. The field valves are then connected, right here, to the supply line at the head of each zone. These are electric valves and are controlled by a controller that the farmer programs. However, manual valves can also be used. The valves then feed the water through the supply manifold line at the head of each zone. Those are the red lines shown here. These lines are smaller PVC pipes. They range in size from about 1 to 4 inches in diameter. It is this line that each dripper line is plugged into. Dripper lines have been previously pounded into the field using an injection plow at a depth of between 12 to 14 inches deep. Lines are usually spaced at 40 to 80-inch intervals. The water drips from an emitter inside the tubing, which is similar to a little maze that creates a turbulent path, causing the water to drip out instead of spurt. And finally, at the end of the system is the flush manifold PVC line, shown here by the green. These lines tie the system together, and each dripper line is plugged into the flush manifold line. This line has several small valves placed above the ground that are opened several times throughout the year so that the farmers can flush out any particles that may have gotten into the dripper lines. All of these components work together to efficiently water your crops, and without one component fully functioning, the system would not work properly. So, just what are the reasons that SDI is really catching on? With systems now operating for over 20 years, the irrigation industry no longer looks at SDI as an experiment. An interview with a crop specialist, Warren Moulter, helped me to realize the many advantages that have proven themselves. Some of these main advantages are as follows. First, energy saving and conservation, because the water is delivered exactly where it is needed to be, at the roots. Next, there is little to no evaporation. Because the water hardly ever comes up to the surface, evaporation is virtually eliminated. Which leads us to healthier plants that have less disease. Another advantage is fertilizer management. It is easier to fertilize because fertilizer is injected into the system instead of broadcasting over the top. And finally, one of the largest advantages of all, higher yields. Fields that have drip systems are consistently out-yielding those that are irrigated by center pivots or furrow irrigated. Kay Chandler, a cotton agronomist specialist, quoted, "As agronomists learn the method of using a drip system to its fullest potential, yields continue to rise." End quote. There are, of course, some disadvantages that should be pointed out. First, a drip irrigation system can be very management intense. Running a drip system can at first seem intimidating. There are new procedures that should be learned in order to get the maximum benefit from your system. Secondly, because the water is running is not visible, some farmers have trouble believing without actually seeing what is going on with their crop. Finally, one of the leading disadvantages is the large initial investment, costing anywhere from $800 to $1,500 per acre, as stated by a report from Colorado State University. But with the high and ever-increasing cost of energy, many bankers in the Plain and West Texas area are pushing farmers to make this investment. There is also a government program called EQIP that is available in many counties to help pay for part of the system. As you can see, subsurface drip irrigation is no longer a wild and crazy idea, rather a substantial improvement for farmers. The industry is growing rapidly, and it is not uncommon to hear farmers speak about their drip irrigated fields. So, the next time you're driving through West Texas and you wonder why one cotton field looks so much better than its neighboring field, the answer may be very simple. It is what lies beneath: subsurface drip irrigation. Kristen Hilger.